Hi viewers, welcome to my channel Energy Derive. Do you know how a flip-flop circuit works? Today we're unveiling the working of a flip-flop circuit in details. Most people don't actually know how the LEDs turn on and off in a flip-flop circuit. Are you one of them? Stay tuned for the detailed explanation of a flip-flop circuit. We will also design a flip-flop circuit using transistors. Please like, share and subscribe to my channel. Before we proceed, I recommend Proto Circuit Simulator app for everyone who wants to design any kind of electronic circuit. It is professional and accurate, that's what I use for my experimentation. It's available on Google Play Store. What is a flip-flop circuit? A flip-flop circuit is a digital circuit that can store a single bit of information in a binary system. It can toggle between two stable states depending on the input it receives. The two states are typically designated as set and reset, and the flip-flop can maintain its state even after the input signal disappears. Flip-flops are often used in computer memory circuits, clock systems, and counters. There are several types of flip-flop circuits, but today we are going to focus on the flip-flop circuit made with two transistors. Before we go on with the explanation, we have to first understand certain parts of the circuit. In the circuit, you can see that we have capacitor and a resistor connected in series, which is often called RC circuit. With the capacitors, they would allow current to flow through them during their charging state, but they would block DC voltage when they are fully charged. Looking at transistors, we know that transistors allow current to flow from its collector to the emitter by applying an amount of current through its base. Now let's get into the main circuit. When we apply voltage to the circuit, the capacitors begin to charge. But due to its different charging speeds or states, one gets fully charged before the other. The capacitor C2 fully charges faster and blocks the DC voltage from flowing through it. Then it begins to discharge its voltage through the base of the transistor T1 connected to the other capacitor C1, which is still on charging state. This forms a complete circuit for the charging capacitor C1 to work, which turns on the LED D1. When the charging capacitor C1 also fully charges, the discharging capacitor C2 would be fully discharged. Then the fully charged capacitor C1 would begin to discharge its voltage through the base of the transistor T2 connected to the discharged capacitor C2. Then the discharged capacitor C2 also begins to charge, which forms a complete circuit for the charging capacitor C2, which turns on the LED D2. From this explanation, we can see that the capacitors at different point in time, one after the other subsequently opens its circuit when fully charged, and then closes another circuit when discharging. That's all about today's video. You can check out in my previous videos about how to use a transistor as a switch and how to make an automatic night switch. I'll leave the links to these videos in the description. Thank you for watching.